Hey guys, welcome to another lesson. So today, a fresh new topic on probability, and we're going to cover discrete random variables today, and the next lesson, continuous random variables. Now this topic, part of the new syllabus, which was introduced about 3 years ago now, and the questions that we have, past papers that we have on these, are not that many, all right? We've only had 3 years in New South Wales, but what people don't sort of realize, what teachers don't realize, is that this part of the topic has been part of the Victorian syllabus for a while, and I think it's part of the Queensland as well. So you'll see a number of past papers today coming from places. If it's before, prior to 2020, those past papers come from Victoria. So I thought I'd dig into that resource just to bring forth some questions, right, that I can cover. So today, discrete random variables. And then next lesson, continuous random variables. Now, if you haven't already done so, please subscribe to the channel and give the videos a like. That'd be appreciated. Thank you. Let's get started. So a bit of theory before we, I guess, dive into the past paper questions. Now, I'll start with discrete random variables, or DRV, as I like to call them. Now, the distinguishing aspect, right, or definitional aspect between a discrete random variable and a continuous random variable is that discrete random variables are countable, right? So, for example, if you were looking at the number of students, right, as a random variable, those numbers of students can be counted, 1, 2, 3, etc. If you're talking about car crashes, right, the number of car crashes can be counted, right? So therefore can be represented by a discrete random variable. Continuous random variables are random variables that have infinite number of infinite amounts. So for example, the heights of students, right? Because whether you like it or not, whenever we're measuring heights of students, generally they're rounded up. So two people might seem like they have similar heights, so 167 centimeters, for example. They're not, because if you take it to the nth, 100th or 1,000th decimal place, they'll be different. So the heights of people, or let's say the weight of people or students, or the in rainfall over a day, right? The height of rainfall or the amount of water in the rainfall, that can be different, right? Infinitely different if you sort of take it to the nth degree, right? Or the nth decimal place. So continuous random variables just means there's infinite solutions, right? We deal with that next week. Also, as part of the new syllabus, generally speaking, discrete random variables are taught in year 11 and continuous in year 12. Now, there's a very simple reason for that, because continuous random variable needs integration, right? You don't do integration till early mid year 12, so can't do that. Can't do the continuous random variables until you do that topic. While discrete sort of stands on its own 2 feet, you won't need integration or any calculus. So now I just want to put forward 3 points, right? 3 sub points. The first point is this, I call it the total probability rule, right? We know that back in year 8, year 9, year 10 probability, that the sum of all probabilities equals to 1. And in this topic, it's sort of denoted by the sum of all the px's, right? Equals to 1, right? Very straightforward, right? Just highlight that first point. Second point is that expected values, right? So expected value is another phrase or term for the mean or the average, right? And in this topic, so it's denoted by EX, right? And it's worked out by taking the sum of X's times PX's, right? Pretty straightforward. So if you have a table, which you'll see later, for each one of these questions generated as a table, you just multiply the X's and the PX's, right? And the third point here, actually there's 2 sort of points, right? The first one is variance, right? And variance of R of X is given by the expected value of X squared, or the second moment, right? They call it in statistics, while EX is the first moment, minus the expected value squared, yeah? Now, 2 things need to be said about this. Firstly, sorry, let's highlight that. Firstly, the notation for EX can generally be simplified by mu, which makes this guy also mu, right? Yeah. Secondly, whenever we talk about x squared, right, just be absolutely clear in its calculation. E of x squared is the sum of x squared times px, right? Yep. And then for questions that I'm not sure whether there's a question here today that has, but if we're looking at standard deviation, then, right, which has, statistically a better use, right? Mean and standard deviation are usually used to do things like normal distributions and stuff. Standard deviation, it's just the square root of r, right? All right, guys. With that in mind, I mean, there's a lot more things I can say and put together for you, right? As if I was teaching you a full lesson, for example, mode, median, etc. But for now, let's just move on from here, right? I want to do a few questions, touch on a few past papers that are common, right? Let's dive right into it. So the first one is from Sydney Grammar 2020, right? So this question is very classic, right? They give you a table. There's X values on the top, right? And it tells you that it's a probability distribution function, right? And that's important because the moment it's a probability distribution function, then the total probability rule kicks in. And what does that mean? It means that the sum, right, of all these, well, let's use the notation, right? I use p little x, but I use this, equals to 1, right? Why is that important? That would allow us to find the value of m, right? With that, and look at that, 4 marks, geez. Right, that's probably like 2 marks, and then the expected value thereafter. This is actually quite generous. I think it's also quite generous here in context of the year 2020, because this was the first year of the new syllabus. So this is the first time Sydney Grammar was asking these types of questions. So I think they gave it more mark, and over time, the marks for these questions probably decrease. This is probably like a 2 marker now, right? So first one, to find m, use a total probability rule, and then we'll use the expected value. So if the sum of all probabilities equals to 1, then quite simply add up, 1, 2, 3, and 4, plus 1 minus 8m, plus 4m, plus 0.1, that equals to 1. Easy, right? So clean that up, what's that? 6. So 1.1 minus 2m equals to 1, 2m equals 0.1, m equals 0.05. Yeah. Now, if you had time in the test, I'd sub all that into the 4 boxes and make sure it adds up to total of 1. Yep, sure it does, guys. And then that will give you your 2 marks in this case, and then expected value, right, will quite simply be the sum of all px's multiplied by x, right? So what that means is I take m times that, 1 times that, plus this guy times this guy, etc., right? So let's do that. So actually, before I do that, let me just get rid of this. I'm actually going to sub the numbers in, right? So if I sub 0.05 into all these values, 2 times that equals to 0.1. 1 minus 0.4 is that 0.6. 4 times that would be 0.2. Perfect, right? Because I'm going to use these pink values here along with the top row to actually do the expected value. So there'll be 1 times 0.1 plus 2 times 0.6, 3 times 0.2 plus 4 times 0.1, right? If you punch that into your calculator, the expected value should be, what, 2.3? Done. How's that? Right, very straightforward. I thought I'd begin here. Now, a lot of questions in past papers, trial papers, HSC, when it comes to DRV, would have either one variable, so right now m's missing, and the second most common one, or sorry, the most common one probably, is where there's 2 variables missing. Let's do one with 2 where you have to solve simultaneously, which means I'll probably give you 2 facts, right? Let's have a look. This one from Gosford. So you can see here, there are, so once again, DRV, right? So that means adds up to 1, 2 variables missing, right? Now, when they give you 2 variables missing, you got to solve simultaneously, which means they give you 2 facts. Where's the second fact? Here, right? So what's the first fact? The first fact, because it's a, oh, sorry, not a DRV, it's a probability distribution, right? If it's a probability distribution, it represents all probabilities. That's saying that the sum, total probability rule kicks in, right? Of Px equals 1. And then they tell you that the EV equals that. With these 2 facts in mind, right? We can then solve simultaneously for A and B. And that's what it tells you, solve simultaneously. That's 3. Once again, 3 marks. 2020 is probably worth 2 marks nowadays. And then find var, okay? Pretty stock standard, right? So today, nothing too hard. This topic, I mean, I don't think it's too bad, right? Continuous one might have a few more tricks, but this one here, very standard, right? Let's have a look. So let's use total probability rule. The sum of all probabilities equals to 1. So I'm just going to go A plus B plus 0.2, 0.15 plus 0.13 equals to 1. Very straightforward, guys. A plus B equals 2. Now let's have a look. What's that? I might need a calculator here. My apologies. So I'll go 0.2 plus 0.15 plus 0.13, 0.48. Chucking on the side 0.52. Is that okay? Yep. So simultaneous equation, number 1. Yeah. Number 2, if the expected value is 0.55, right? Then remember, each one times itself. Oh, this one's actually, simultaneous is really easy because one of them 0. So -1 times A plus 0 times B plus 1 times 0.2 plus 2 times 0.15 plus 3 times 0.13 equals 2, 0.55 now. So it went off screen. Let me bring it back in. Guys, the beauty about this one is that this one here actually zeroizes, right? So you don't actually need to solve simultaneously. So minus A plus, now, if you added all that, I believe 0.9. Yeah, someone check that, please. Right, 0.55, and then A just equals to minus that, so 0.34. So you actually, yeah, don't need to solve simultaneously. So if you call it number 2, yeah, and you sub 2 back into 1, you should get B equals to 0.18. Right, and that's 3 marks. Wow, nice. Yeah, 3 marks without a real sort of simultaneous equation solve. Part B then, yeah, to do var. Now, some teachers, because the formula for var is E of x squared minus E of x squared. Now, we already have E of x, right? That is 0.55. To find this now, a lot of teachers get carried away and they make their students do this, right? They make their students go, can you please put an x squared and square the top to, so what, -1 squared, 0, 1, 4, 9, right? That's fine. I mean, without doing that, right, you can just basically do it, right? You can just go, well, E of x squared is just basically this guy here, right, equals 2. Yeah, it'd just be x squared times the probability, right? So let me just click over so I get, oh, okay, you know what, before I do that, for A, I put that probability in so I can visualize it, 0.34, and for B, 0.18, okay. So it'll be -1 squared times 0.34 plus 0 squared times 0.18 plus 1 squared. So instead of pulling that extra row, I just tell my students to just put the square on the working out and just punch it all in your calculator. 1, 2, so the green actually goes longer than that. plus 2 squared times 0.15 plus 3 squared times 0.13. Yep, and then subtract off 0.55 squared. Yeah, so the green's that, and also just be clear, the pink is this, right? Punch in the calculator. I believe your var should be, or your variance should be 2.0075. Yeah. So guys, nothing hard about that, right? It's a classic question where, well, actually, it's easier than the classic, where classic sort of makes you solve it simultaneously. This one here, the b sort of cancelled out in the second equation and you just found a immediately. That was no fun, but that's how you do it, right? That's how you do these questions. See the next one. Now I've got 2 more questions prepared. Now, this one here, VCE, that's the Victorian equivalent of the HSC, right? From 2010 had a question like this. So I like to, by looking at the Victorian questions, you can tell that they've had a longer time to sort of ask these questions, because their questions are deeper and richer and just more varied, right? While we're in New South Wales still, the questions are still very textbook, right? Very textbook, very rudimentary. Well, these ones here, a bit more to it. So discrete random variable, find p. So once again, one letter, so it's not simultaneous. So you can see, because it's a probability distribution, then the sum of all probabilities should go to 1. And I think it might be like a quadratic or some sort, right? Yeah, so let's deal with it. So just nice, right? Just different. So sum of all probabilities equals to 1. P squared plus p squared plus p on 4 plus 4p plus 1 on 8 equals to 1. All right, oof, that looks ugly. Times it by 8 maybe. That's 2p squared times it by 8, 16p squared. Plus times it by 8, 2p. Times it by 8, the 8 goes away. Times it by 8. Let's bring everything over. 16p squared plus 6p. Was that minus 7? What the heck? Can that be factorized? Please tell me it can be. All right, okay. Yep. Okay, so what's that? 2p and 8p maybe. 0, 7, 14 and 1. 14, 1, no, 14, 8, yeah, perfect. So 7, 1, positive, so that's plus. It's minus, therefore p equals to either half or -7 on 8. Now, what's important is, even though these are squared, these ones aren't, right? P, or all probabilities, all px's have to be greater than, oh, sorry, more specific than that, right? 0, px, 1, right? So not only is it positive, it can't be bigger than 1, right? All the probabilities. Yeah? So if I sub negative in, won't be, so this one's wrong. Therefore, p equals to half only. Yeah. Not sure how many marks there are, but I suspect maybe 2-3 marks for this question. Yeah, quite nice. All right, so all the probabilities are greater than 0, right? Yeah, keep that in mind. So guys, I've got one more question. So this isn't going to be a long video, right? Just give you that, a few types of common questions. Next one's also from the Victorian syllabus, from institution called Kilbaha 2009. Just different, right? I thought it's cool to have like a different sort of function, in this case, trig, right, to do so. So let's see. Probability distribution. So once again, total probability rule kicks in, right? Sum of all these 2 probabilities equals to 1. That's how I find k and then expected value, right? So classic. So 3 marks for the first one. So part A. Let's see. So the sum of all probabilities equals to 1. So in this case, sine k plus 2 sine squared k equals to 1. Looks like a quadratic in terms of trig. Move the 1 over. 2 sine squared k plus sine k minus 1 equals 0. Factorizable, yeah. 2 sine k, 1 sine k, 1 positive, so that's plus, that's minus. Therefore, sine k equals to a half sine k equals to -1. Right? Let's have a look. So, using all stations central or angles of any magnitude, right? Sine k is in the first, if it's positive, second quadrant, right? Which is theta 180 minus theta. Let's issue 12. That's pi, yeah. So pi minus theta. Yeah. Inverse sine that, so k equals to pi on 6, and pi minus that, which is 5, pi on 6. Sweet. Now, oh, wait a second. Sine k equals -1, right? I know that, see how this probability sine k, that can't be negative. So in this case, no solution, right? This one here, no solution. Yeah, don't need it. So k equals to these two only. Does that make sense? Because sine k can't be negative, right? Because it's a probability. Therefore, those are my only two solutions. Now, once you do that, expected value, let's have a look. Right. Shouldn't be too bad. It's only worth 1 mark. Yeah. So I know that expected value equals to sum of all probabilities multiplied by x. Yeah. So in this case, it's 1 times that, 2 times that. Cool. So that equals to 1 times, now sine k. Now, because sine k, actually I have it here, right? Yeah. Sine k equals a half. I'm going to use that, right? I'm going to use my big brain there. That's a half plus 2 times 2 sine squared k. So that's like half squared. Does that make sense? Because it's like sine 1 times sine k, which is half, 2 times 2 sine squared k, which is 2 times 2 sine half squared, right? And that's my answer. So let's see, what's that? That's a half. That's 1.5. Right? Nothing too fancy about that. Guys, short, brief video on discrete random variables. Just thought I'd cover that base. Next lesson, continuous random variables, right? Just to cover off the probability random variable related topic, right? If you like that video, give us a like, subscribe, tell your friends. I'll see you in the next video.